Alright, hey folks, this is the review answer key. So first thing, convert each measure to radians. So when we do these two problems, like these two types up here, we have either to multiply by pi over 180 or 180 over pi. And if you're turning into radians, you want the pi on top. And if you want to turn into degrees, you want the degrees on top. So basically I just got to take 48 times pi over 180, and then really we're just reducing 48 over 180. The pi is kind of along for the ride. So let me get a calculator here, and 48 over 180 reduces to be 4 over 15. Because I think 12 goes into the top and the bottom. And the pi is still there, don't forget that. So this one, same deal, we're multiplying by pi over 180. So really we're going to reduce 230 over 180. Now that's an improper fraction. I don't really want the decimal 230 over 180. I don't want that, but even when I turn it into a fraction with this button here, the F to D, fraction to decimal, I still don't want a mixed number, so if you look right below it, this is how you turn it into an improper fraction. Now if you have a graphing calculator, it kind of does this automatically. 23 over 18. Now I also could have gotten there a little quicker by just dividing the top by 10 and the bottom by 10. Wanted to show you how to do it on the calculator though. Alright, so same deal here. This problem, or these problems, this P is for pi. So, you know, I don't know. So that pi and that pi cancel, and you're just going to take 180 divided by 12. I was having issues with that font and getting the pi symbol, so it's 15 degrees. Same here, 7 pi over 4 times 180 over pi. The pi's cancel. You're really just doing 7/4 times 180. 315. That's one on our unit circle. And then kind of the same idea here. You just have to remember to do 180 over pi, really, because it's 3/5 times 180. Easy peasy, 108. Alright, so switching from degrees to radians, not hard. You just got to kind of keep the pi along for the ride. Switching from radians to degrees, even easier once the pi's cancel. Here, use an angle measure of negative 210. So I know where regular 210 is, because like here's 180, 210's down here, right? Negative 210 would be going backwards. So I'm starting here still. This is my initial side, but my terminal side would be up here. And I want to show that I went the wrong way by doing a little arrow there. So that is a negative 210 degrees angle. If you look at our unit circle, we have a regular 210 would go this way. A negative 210 goes the other way. What quadrant? Remember, we label them like this. So that is quadrant 3, Roman numerals. Name a coterminal angle. That means if I have negative 210, I want another angle that ends in the same exact spot, but lands between 0 and 360. So really, with these, you're either adding 360 a bunch of times or subtracting 360. So if I take negative 210 plus 360, I get a 150 degree angle. That lands in the same spot, but goes there the forward way instead of the backward way. Alright, moving on to this. Same deal. We're going to have to draw a 675. Now, if you don't know where 675 is, neither do I. So I'm going to take 675 and start subtracting 360 until I know where that angle really is. So I got to draw where 315 is. And 315 is like, you know, it's like a 45 down here, sort of. So there's 315, but to show it 675, I have to show that I went around the circle one whole time. There's 360. And then all the way around there again to make 675. That's what it would look like to show you're actually doing 675, not 315. Once again, this is quadrant 4. You can check up above for all the quadrant numbers there. And a coterminal angle, we just found one, 315. Because that was 675 minus 360. So you can tell the previous problem we added 360, this problem we subtracted 360. You know, sometimes you have to subtract more than once. Alright, now we got radius and arc length. So there's a crazy formula for this. S was your arc length, is 2 pi r times degrees over 360. So if I have a radius here, I'm going to find the length of this arc. 2 times pi times 12 meters times degrees, which is 90 in this problem, over 360. So really, I'm just typing this in. 2 times pi times 12 times 90 over 360. Boom. 18.85 meters. Remember, the problem had meters to begin with. It's going to have meters at the end. Same deal here. We're just doing 2 pi r. So we're going, arc length is 2 times pi times 2.4 feet times 120 over 360. So this portion of the circle. 2 times pi times 2.4 times 120 over 360. Boom. 5.03 feet. Just keep your units on there. It'll be awesome. Alright, moving on. Now we're getting to find the exact value of each. This is, that means you're not typing it in your calculator. You're going to your unit circle. So if you say 390, I'm like, what's 390? But if I take 360 away, I know that this is really just asking what is sine of 30. So I go to my unit circle, handy dandy unit circle. I go to my 30-degree sprout here, which is blue, and I have to remember which one of these is sine. And I hope you've done it enough. Sine is the y part. Okay. Now we're doing tangent of 3 pi over 2. So 3 pi over 2 is 270 degrees. So the x part is 0 and the y part is 1. If you remember, tangent is y over x. So sine is just the y value. Tangent is y over x. So if I go back to this problem and I look, what is the y value? Y value is -1 and the x value is 0. So I'm going to say -1 over 0, which you can't divide by 0, so that one's undefined. And then cosine of 210, kind of the same deal. We grab our picture, we go to 210. Which one of these two numbers is cosine? The x part. Cosine is x. So I'm going to grab the x part and say that's -3 over 2. Easy peasy, right? Let me go to this one. What is secant of 7 pi over 4? All I need to do is flip cosine of 7 pi over 4. So if I know cosine of 7 pi over 4, then I just have to flip it. So let me find what cosine of 7 pi over 4 is. Alright, where's 7 pi over 4? There it is, this orange one. Cosine would be the x part. There it is, radical 2 over 2. Okay, and now I have to flip that. So flip it. And I will get 2 over radical 2, which is ugly, and we got to fix it. And that cancels, and you get radical 2. Oops, not negative, just. Similar to this, secant of 150 means if I knew sine of 150, I can just flip it. So let me find sine of 150. Here's 150, right? Sine is the y part, which is 1/2. I just have to flip that. So we'll call it 2 over 1, aka 2. Okay, cotangent of 2 pi. I could find tangent and then flip it, but remember how tangent was y over x? Well, cotangent is just x over y. I don't have to like flip it twice. So if I want to find cotangent of 2 pi, I go to 2 pi, which is right here, that point, 1, 0, and I write x over y, which in this case would be 1 over 0. And 1 over 0 is undefined. If you would have had 0 over 1, that would have been an answer of 0. Alright, so this one, we did this a while ago. It says point P is negative 3, 7. Plot this point, draw the angle in standard position and resulting right triangle. So we did this a while back. You draw this angle, so we're going to go negative 3, negative 7. So it's going to be down here somewhere. 1, 2, 3. Boom. Now, sometimes people do this and then get weird. Remember, when we draw our triangles, we always draw it to the x-axis. So I'm looking at this triangle here. And we're talking about this angle right here with the x-axis. There's angle Q. Okay, so if I'm looking at this, my x part is negative 3, it's left 3. My y part is down 7. I have to do a little work to find this hypotenuse, right? Because here's opposite, here's adjacent. I'm missing my hypotenuse, so how am I going to find it? A squared plus b squared equals c squared. If you don't put parentheses around there, you're going to get in trouble. So I just do it without a calculator. It's probably easier that way. And we're going to have, what's that? That's 58 is c squared. So c is radical 58. So I'm just going to leave that ugly number. Radical 58 is your hypotenuse. Okay. So now what's cool is good old Sohcahtoa. If you ask me what sine of this angle is, sine is opposite over hypotenuse. So opposite is negative 7 over hypotenuse, which is radical 58. And that's kind of ugly, so you're supposed to multiply top and bottom by radical 58. And we'll get, what's that going to be? Negative 7 radical 58 over 58. I don't think those reduce. No, they don't. Okay. Cosine would be adjacent over hypotenuse. So I go on this picture, adjacent is negative 3, hypotenuse is radical 58. So once again, I got to clean it up a little. And your end answer is negative 3 radical 58 over 58. Boom. And then tangent's a little nicer because it's opposite over adjacent, like Sohcahtoa. So opposite is negative 7, adjacent is negative 3. I should probably just get rid of both those negatives and call it 7/3. Now, the good news is, if I know these three, I can just flip the fractions. So this one's 3 over 7. This one, I could get ugly, but if I went back to the original, just remember if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. Basically, it's better to flip the original problem here, this guy, before I did the fixing, than to flip this, because then you'd have to fix it. Same deal here. I could flip this, but that would be more work. If I flip the original opposite over adjacent to be, opposite over hypotenuse to be hypotenuse over opposite, it's going to be a nicer answer. That's it. All right. Hope that helps. Practice all that stuff. Look over your notes and homeworks, and good luck studying there.